arithmetic and geometric sequences. Key concepts for arithmetic sequences. A sequence is an ordered list of numbers. They often form a pattern. Each number in the list is called a term of a sequence. A sequence is arithmetic if the difference between consecutive terms are the same. So the sequence A1, A2, A3, A4 to AN is arithmetic if there is a number D such that A2 minus A1 equals A3 minus A2, which equals A4 minus A3, and all equal D. The number D is the common difference of the arithmetic sequence. Extending sequences for arithmetic sequences. Can you describe a pattern in each sequence? What are the next two terms? For part A, we have 5, 8, 11, and 14. Can you see the pattern? If you add 3 to the first term, it gives you the second term. So if we add 3 to 5, we get 8. Add 3 to 8, we get 11. And we add 3 to 11 and get 14. Part B, we have 2.5, 5, 10, 20, and so on. So we can see here that if you multiply 2.5 times 2, it gives you the second term, which is 5, and so on. In both parts A and B, the difference in the sequence is the common difference. The common difference in part A is 3, and the common difference in part B is 2, multiplying by 2. The recursive formula for arithmetic sequences. A sequence is a function whose domain is the natural numbers and whose outputs are the term of the sequence. A sequence can be written using a recursive formula. A recursive formula is a function rule that relates each term of a sequence after the first to the one before it. Let's consider the sequence 7, 11, 15, 19, and so on. The common difference here is 4. So we let n equals the term in the sequence, and we let a to the n equal the value of the nth term of the sequence. So then the value of the term 1 equals a1, which is 7. Then we have the second term, which is a2, and a1, which equals a1 plus 4, which equals 11. Then we have term 3, which is a3, equaling a2 plus 4, which is equal to 15. Then we have term 4, which equals a4, and that equals a3 plus 4, which is 19. The nth term, n, equals a to the n, which equals a to the n minus 1 plus 4. Then the recursive formula for the arithmetic sequence in a to the n equals a to the n minus 1 plus 4, where a to the 1 equals 7. Here's an example 1. Write a recursive formula for the sequence 70, 77, 84, and 91, and so on. So for step 1, we want to find the term of the sequence. A1 equals 70, A2 equals A1 plus 7, which equals 70 plus 7, which is 77, And then we have A3, which is equal to A2 plus 7, which equals 77 plus 7. Then which equals 84. Then we have A4, which equals A3 plus 7, which equals 84 plus 7, which equals 91. We have A to the n, which equals A to the n minus 1 plus 7, which is our recursive formula. To find the value of another term, simply continue extending the pattern. Writing an explicit formula for a recursive formula. An arithmetic sequence is represented by the recursive formula a to the n, which equals a to the n minus 1 plus 12. If the first term of the sequence is 19, write the explicit formula. The first term is 19, so a to the 1 equals 19. We have a to the n equals a to the n minus 1 plus 12. The common difference is 12. The explicit formula for an arithmetic sequence is a to the n equals a1 plus the quantity of n minus 1 times d, which is the general form of an explicit formula. So then we have a to the n equals 19 plus the quantity of n minus 1 times 12. Here we substitute 9 in for a to the 1 and 12 for d. The explicit formula is now a to the n equals 19 plus the quantity of n minus 1 times 12. Given the arithmetic sequence represented by the explicit formula a to the n equals 32 plus the quantity of n minus 1 times 22, what is the recursive formula? So we know the first term is 32 and the common difference is 22. Therefore a1 equals 32 and 22 is the common difference. Therefore we write the explicit formula as a to the n equals a to the n minus 1 plus 22 and a1 equals 32. Geometric sequences. A geometric sequence with a starting value a and a common ratio r is a sequence of the form a times r, a times r raised to the second power, and then a times r raised to the third power, and so on. A recursive definition for the sequence has two patterns. A1 equals a, which is the initial condition. An equals an sub n minus 1 times r for n is greater than or equal to 2, which is the recursive formula. An explicit definition for this sequence is a single formula. A to the n equals a sub 1 times r raised to the n minus 1 for n is greater than or equal to 1. Every geometric sequence has a starting value and a common ratio. The starting value and common ratio defines a unique geometric sequence. Let's look at problem number 1. To find the common ratio between adjacent terms in a geometric sequence, you must determine if there is a common ratio. Here's part A. What is the common ratio for the sequence 20, 200, 2,000, 20,000, and 200,000? To go from 20 to 200, you multiply 20 times 10, which equals 200. To get from 200 to 2,000, you multiply by 10 again. We see that each term is multiplied by 10, so the common difference then, which is r, equals 10, and the sequence is geometric. Here's problem 2. What is the common difference for the sequence, and is it geometric? We have 3, 6, 9, 12, and 15. So we see the first term is 3, and if we add 3 to it, we will get 6. If we keep adding 3 to the next term, we get the sequence 3, 6, 9, 12, and 15. This is not geometric because it does not have a common ratio. However, it has a common difference, and therefore it is an arithmetic sequence. Finding the recursive formula and explicit formula. Example 1. Find the recursive and explicit formulas for the sequence 7, 21, 63, and 189. The common difference is 3. Each term is multiplied by 3 to get the next. Recall the formula a sub n equals a sub n minus 1 times r, for n is greater than or equal to 2 for the recursive formula. The initial condition is a sub 1 equals a, and a sub n equals a sub n minus 1 times r. Then a sub 1 equals 7, a sub n equals a sub n minus 1 times r. A sub 1 equals 7, and a sub n equals a sub n minus 1 times 3. The recursive formula is a sub 1 equals 7, and a sub n equals a sub n, and a sub n minus 1 times 3. We know the common ratio is 3, so we use the formula a sub n equals a sub 1 times r to the n minus 1. A to the sub n equals 7 times r raised to the n minus 1. Then the explicit formula is a sub n equals 7 times 3 raised to the n minus 1.